So this time I have the integral of sine squared x dx, and I'll need a trig identity. We have two trig identities for sine squared x. We had sine squared x is 1 minus cosine squared x, and I have sine squared x is 1/2 times 1 minus cosine 2x. And my first thought, if I was sitting in your place, my first thought would be probably to use that first one. And if you tried that, it didn't work. Look, if you try the first one, this is, by the way, this is not correct. But, you know, I want you to kind of see, sometimes, or it's not the way I want to proceed. Let me say it that way, because I won't make a mistake, I hope, but it's not going to get me anywhere. Sometimes trying things one way, another way, is really the best way to learn math. You got to struggle with these problems sometimes. So if I try this, the integral of sine squared x dx is the integral of 1 minus cosine squared x dx. Well, I could write that as two separate integrals. That's the integral of 1 dx minus the integral of cosine squared x dx. And if you look at this integral, that's about the same level of difficulty as the one I started with. And then I would try, cosine squared x is 1 minus sine squared x, correct? And I will end up getting something like x equals x or something like that. Okay, you can try it, but I'll tell you, we come up empty here. So we're going to have to use this other identity. This is the one where you're going to have to go with that other identity that I talked about. So the integral of sine squared x dx equals the integral of 1/2 times 1 minus cosine 2x dx. Now see that 1/2 in the front? And I want to factor that out. I can factor constants out. I cannot factor out things that have variables in it. But I can factor out the 1/2. So it's 1/2 times the integral of 1 minus cosine 2x dx. Now, this is two separate integrals. So 1/2 times the integral of 1 dx minus the integral of cosine 2x dx. Sometimes I'll split them into two separate integrals. Sometimes I'll just leave it the way it was. This one I like to split in two separate integrals. I know what to do for this guy. What's that going to be? X. What about this one? That's U-substitution. That's a U-substitution problem right there. Now, you might have learned the formula for that, and if you did, that's fine. But I like to go ahead and show the U-substitution. So this would be my 1/2 is multiplied by both. I'll multiply it at the end. The antiderivative of 1 is x. For this part, u equals 2x. And what's the derivative of u? 2dx. So dx is du over 2. So this I'll have minus the integral of cosine u du over 2. Look, there's another 1/2 in here. I'm going to take this 1/2 out. 1/2, okay, from that we took out previous, x minus, here's my 1/2 du over 2, the integral of cosine u du. The integral of cosine u du is sine, yeah. So it's 1/2 times sine u, right there. I'll put on the plus c. Okay, we'll go to a new page. Put 2x back in for u. 1/2, okay, x minus 1/2 times the sine of 2x plus c. This 1/2 that's on the outside, I will go ahead and distribute it. You could keep it on the outside if you want. 1/2 x minus 1/4 sine 2x plus c. Okay, and that is what I will call my final answer for this one.